Well, in this brief video, we're going to show you how to find the conditions for cost minimization when the production function underlying the whole thing is the Cobb-Douglas production function, that kind of exponential production function that we examined earlier on in the production section. So here's the problem we're going to look at, but this time in a specific case where the production function is Cobb-Douglas. We're going to minimize cost, which is the sum of expenditures on labor input and capital input, subject to the constraint that output, we'll call it something like Q bar, is given by this production function, A L to the alpha power, K to the beta power. And as we saw in the last video, the way you attack this problem is to set up the Lagrangian expression, and we'll call that Lagrangian function C star, and that's equal to the thing that you want to minimize, PLL plus PKK minus the Lagrangian multiplier multiplied by the production function, written in a form where it's equal to 0. And we know from the earlier problem for cost minimization what we have to do is minimize this Lagrangian function with respect to L and K and the Lagrangian multiplier, lambda. And we want to set these partial derivatives equal to 0. And in the case of this one, we have PL plus lambda times alpha, L to the alpha minus 1, K to the beta. And here we have PK plus lambda beta L to the alpha K to the beta minus 1. And of course the third partial derivative down here is just going to be equal to the constraint Q bar minus A L to the alpha K to the beta. So using the first two of these terms set equal to 0, we know that the rule for cost minimization says the ratio of the prices is equal to the marginal rate of technical substitution of L for K. So with these equal to 0, we see that minus lambda is going to be equal to PLL over alpha times Q. And from the second equation, minus lambda is equal to PKK over beta times Q. Two things equal to the same thing are equal to each other. So we see that in this case, PL over pk is alpha k over beta L. Now this is pretty dull stuff, you would think, but what we have here now is three equations and three unknowns. We have the definition of cost, we have the production function, and we have the rule for choosing the cost minimizing amounts of the inputs. And there are three unknowns, C, K, and L. The firm's total cost function is the solution of these three equations and three unknowns for cost as a function of input prices and the parameters of the production function. And we'll show you how that can be worked out. In other words, how you can find the cost function for the firm as a result of solving this cost minimization problem that we've just gone through, both in general and for this specific case where the production function underlying the production process is Cobb-Douglas.